MATLAB can be used to do a least squares fit for experimental data. I have created x and y coordinates for the experimental data for this example. This MATLAB script shows the coordinates for that experimental data, the x and y coordinates. Then, since that is experimental data, I plot that data, plot x comma y, and I am plotting it using the color black with circle-shaped markers. I've also created some sensible labels for the axes and a sensible title for my plot. I have also chosen to select a font size that's a little bit bigger than normal. You will also notice in some of these titles that I have used some Greek symbols. MATLAB allows you to do that by first using a backslash and then the name of the Greek symbol. That is just something I'm mentioning in passing. You can use other Greek symbols where it is appropriate. After creating this sample data, I want to now demonstrate how you can find a linear least squares fit of the data. In order to do that, you can use the polyfit command inside MATLAB. If you use the polyfit command and then put in the x and y data, and then specify that this is a first order curve, in other words, a linear curve that you want to fit to the data, you can do that by putting a 1 in for the final input value in the polyfit command. As a result of that command, the variable p will contain the slope and the y-intercept inside the variable p. And that slope and intercept are the values for the line that is the best fit for the experimental data. After having found those slopes and intercepts for that best fit line, I need to construct a best fit line to plot on my graph next to the experimental data. I can do this by creating a new variable x1, and I can make it range from the minimum x value in my experimental data set to the maximum x value in my experimental data set. Then, because I know that this is a line, I can create the variable y, and I can use the slope, which is the first value in variable p, so p parentheses 1 times the x value, so that is like m times x, slope times x, plus the y-intercept, which will be the second value in the variable p. I issue the hold on command so that my previous plot does not get erased when I add the least square fit line. So now I can plot x1 comma y1 and choose that to be a blue line. I can also create a legend now for this plot that now will contain the experimental data as well as the line for the least squares fit. I will also put that legend in the bottom right-hand corner of the plot. Lastly, when you do a least squares fit, it will often be the case that you will want to know what the slope is for that least square line. And so you can do that by printing that to the plot. In this case, I've created a string that includes that information. And I have concatenated several strings together, and then I use the text command inside MATLAB. By using coordinates that are going to show up on the graph, I can place that string of information on the plot. I can also do that for the theoretical value of slope that I maybe knew that I should try to get while I was doing the experiment. In this example, I've stated that that was supposedly 700 pounds per inch. Notice back up here, though, when I created the experimental value that I am going to create a string for, I have used the concatenation of strings command, stringcat, and I say that k underscore experimental fit is equal to, I have rounded the value of the slope and I have converted it from a number to a string, and I've also added the units at the end of pounds, inches. Anyway, you can take a look at those commands and see how they work, and we can now run this script and see the plot that this creates by using the polyfit command. In this plot, you can see the two text items that I added to the graph. You can also see the experimental data as circles, and you can see the best fit or least square fit line in blue for this plot. Hopefully that will help you in the future when you have experimental data and you want to create a least squares fit for your experimental data.